All right, this is the second video that I'm going to make, and we're just going to concentrate on covalent bonds. We'll do ionic and hydrogen bonds at a different date. So what I want to concentrate on is hydrocarbons, okay? And how are hydrocarbons created? All right, so if I write hydrocarbon, then from just the name of it, you should be able to realize that this is made of what? Hydrogen and carbon, okay? And so these are the simplest of all organic molecules. And because they don't have a functional group, they don't have pretty much anything. They are just hydrogens and carbons, and they are based upon the number of carbons that it has, as it determines the name and the structure. And so today we're going to concentrate on the hydrocarbons that are referred to as alkanes. Okay, alkanes. When we see the suffix ane, we know that this is talking about when it has all single covalent bonds, okay? And that's the key. Right there is the single. And so what I just did in the last video is I took carbon and I created methane, okay? Now, the last time I actually used the Lewis dot structure to show it, but if you think about this time, this is typically how you're going to see the structural formula, and you can think about here's an electron here and here's an electron there. So each one of these bonds, one bond equals two shared electrons, okay? So two shared electrons. As with the last video, I need you to be taking these notes so that I know that you are going to be able to do this. And these are, like the last one was kind of a review, but this is totally new. You can't find it in a book. So I need for you to really kind of concentrate on what's going on. Now, this one right here is referred to as methane, okay? Meth means not methamphetamine, so no ha-ha, but it does have something to do with that. But meth means one carbon, so this has one carbon, and ane means single covalent bonds, okay? So when we're starting to talk about the nomenclature, this is how we're going to do that. And so I'm going to create methane, okay? So this carbon right here has 4 holes. That's an electron, that's an electron, that's an electron, so on. So I'm going to create, now, so there's my 1 electron. And some of my little hydrogens are a little pre-made. So this has 2 electrons, one from the hydrogen and one from the carbon. Okay, so I'm going to put that, go on, Sash. And then I've got another one here, so that's 2. And then we've got 4. And then we've got 6, 8, okay? So this is a ball and stick figure of methane. And if you'll notice that it has a particular shape, it's called a tetrahedral. And that is all based upon the bonding angles. Now, if you're in IB Chem, you need to know about those bonding angles. But if you're just in biology, you don't really have to know about that. So this is just trying to give you some knowledge of organic compounds. So when you see them, you actually kind of know what they are. All right, so this is the simplest of all alkanes. And so actually, does anyone know where methane comes from? Anybody? Anybody? Yep, from a flatulent. Does anybody know what a flatulent is? It's a fart. Okay, so this is how our body releases gas, and the body that releases the gas through is that we release is methane. Now, methane in its natural form is colorless and odorless. And so in coal mines back in the day, they used to put a canary down when they're digging for coal. And so because these pockets of methane would come about, and what would happen is that because it's colorless and odorless, it would kill everybody. So they would take a canary down, and as long as it was talking, then they knew that there wasn't a methane. But when we looked over, they kept an eye on it, and if it died, then they knew that they had methane, and so they would have to evacuate the mine. And so, okay, so I'm going to stop this now.